Hello, Panthers. This video is going to be a review for our basic geometric shapes unit. So in this particular video, we're going to review different topics that we have seen in this unit and review what you're going to see on that unit test. So in question one of the unit test, you are going to have to classify angles that are given to you. And so I can't give this specific answer because you're going to see, or the specific question, because you're going to see a variation of any of these. So we're just going to quickly review what it means to have these different types of angles. So remember that when we're talking about linear angles, a linear angle, you're going to see when the entire angle, the sum of the two line, make a straight line. So when we see here, it's going to be separated, could be separated into two, three, or four, whatever example you may see. You could, like I said, you could see another one coming through and showing you that where whatever gives you that straight angle, like here, straight line, that's a linear angle. And remember that linear angles always go up to 180 degrees. Adjacent angles are referring to angles that are simply side by side. So 2 and 3, they could add up to any measurement. There isn't a set measurement for this because it depends on how wide this line and this line go. But what we're trying to pull with adjacent angles is that they share the same vertex. And remember, the vertex is this here, that point in which the two angles share, because you can see that here angle 2 is consists of this line here where that point meets with our point here for angle 1. They both meet right here. So adjacent angles are two angles that share the same vertex. And then vertical angles are going to be seen as two angles that are opposite of each other formed by two intersecting lines. So as you can see here that they're already circled and they're different colors, but you can see that 1 and 3 are opposite of each other, meaning that if I have a value of 1 as being, let's say, 110 degrees, the value of 3 is also going to be 130 degrees, because vertical angles are also going to be congruent to each other, having the same value. And therefore, when we look at 2 and 4, we see that they are opposite of each other and they would be congruent as well. So here would be 70 and here would be 70. So when we're classifying our angles, linear angles are two or more angles when they are put together that create that straight line equaling to 180. Adjacent angles can be any value, but they're going to share the same vertex. And vertical angles are those that are opposite of each other. And vertical angles, once again, are also going to be congruent. Now, as we continue on in this test, in question 2, you're going to be given a linear angle and told to find the value of that variable. So remember that a linear angle, this entire measurement altogether equals 180 degrees. So if we have two bits of information here, 3x plus 40 and 2x minus 20, we would need to add those values together and equal that 180 degrees and solve, just like we did back in unit 3 from our first semester. We solve for that variable. So we get 3x plus 40, and then we're adding it to 2x minus 20, and it's going to equal 180. And then just using our algebraic skills that we learned back in unit 1, we're going to simplify by combining like terms. So we have 3x and 2x that are like each other. So we combine those for 5x. And then we have 40 and 20. So we're going to have 40 minus 20, which is going to give us a positive 20. And then we're still keeping that 180, so we're going to drop the 180. Now we can't combine 5x and 20, so now we've got to move this 20 to the other side by doing the opposite, which is subtraction. Those cancel out, leaving me with simply the 5x equals 180 minus 20 is 160. And then we're able to divide that out. So if we divide both sides, because remember, we're trying to get x by itself, so we move that over to the other side. And when we move that, if 5x is showing multiplication, remember the opposite of that multiplication is going to be division. So we divide both sides by 5. These cancel out, leaving me with x equals 160 divided by 5 is going to give me 32. So our value here is 32. And so that is what we're being asked to do in question 2. Remembering that a linear angle equals 180 degrees, you simply pull the values from each angle, add them together, and equal them, set them equal to 180. Now, as we continue on with this review in question 3, once again, this is kind of, you can see lots of different things happening here, but you're trying to identify an angle measurement. And so depending on what type of angle measurement you're given, you're going to be given one value, one angle measurement. And you can find, for example, if we were to come over here and look at this one right here with the 8 angles, if I gave you the measurement for just angle measurement 1, you could find every other value based off of one single measurement because of the congruent rules. So when we're looking at corresponding angles, we can see here that they're the same color. As we're looking through, we can see that angle measurement 2 and 6. So if I knew the measurement of angle 2, let's say, was, 90 degrees. Actually, nope, not 90. Let's go ahead and say 80 degrees. Let's say 2. We knew 2 was 80 degrees, but I don't know the value of 6. Well, I could state that angle measurement of 6 equals 180 degrees because they are corresponding angles. So you can identify values. Just like if I was to come over here and let's say on our alternate, let's say I knew angle measurement 1 and I was asked to find the measurement, let's say that that's 100. I would be able, let's say, if I'm trying to figure out what the measurement of angle 8 is, well, I could say that I know that it's going to be 180 or 100 degrees because they are considered to be alternate exterior angles. When we have classification of angles, the whole purpose of classifying them is so that we can help find those values. Because once again, let's say we're trying to find, the value, let's say in this case, maybe I wasn't trying to find 8, maybe I was trying to find the value of, let's say I have coming over here to my other example, alternate interior angles. If I have the value here for 3 and I know that that value of 3 is 80 degrees, and I'm trying to figure out what 6 is, once again, I can tell you that the value of angle 6 is 80 degrees because they are alternate interior angles. So when you're trying to identify an angle measurement, first identify what type of angle it is. Is it a corresponding, an alternate, exterior, alternate interior? Are they vertical angles? Because once again, kind of going back to what we talked about in the first examples, if I know that this is 110 degrees and I'm trying to figure out what the measurement of angle 3 is, well, I can say that the angle measurement of 3 equals 110 degrees because they are vertical angles, and vertical angles are going to be congruent. Same thing if we are given something like this, and I know the angle measurement of 1 is, let's say, 100 degrees. And I'm trying to figure out what 2 is, once again, because it is completes an or a linear pair, right? That linear line, we know that the combination of those two are going to equal 180 degrees. Well, 100. What's missing would be 80 degrees. So that would be the value of our 2. So knowing our facts and of identifying our angle types and classifying them is going to help us with identifying those angle measurements as well. Now, in question 4, we're using our exterior angles of a triangle theorem and equation format that we learned. And so remember that the formula we use for that is we state that angle A plus the measurement of angle B equals the measurement of angle C, or that exterior angle. So really that's BCD. So angle measurement BCD. So we know which angle measurement here because there's 2 a part of C. So I know that this is going to be BCD because it goes between those lines. So angle measurement A plus B equals that exterior angle here. And so we're just going to simply plug in the values that we know into our formula. And so we see that angle A equals 50. So we're going to plug in that value. Angle B is going to be 60. So we plug in 60. And so we're trying to find that value here. So we simply 50 plus 60 gives me 110. And so the measurement of BCD equals 110 degrees. You're simply plugging in your values to find them out and solving for whatever piece may be missing. So remember, angle A plus angle B equals that exterior angle of C. Now in question 5, we're going to be using that triangle inequality theorem. Now remember that this is a formula that you do not necessarily need to have memorized. It will be provided to you on the state testing in your formula chart. But what it's stating is that basically that the sum of 2 sides will always be greater than that third side. So whatever 2 sides we know, because when we're given an example of a triangle has 2 side lengths of 15 inches and 14 inches. We don't necessarily know if that's A, B, or C, but it doesn't matter the value of it because as long as we're adding 2 sides together, B and C, it's going to be greater than the third side. A and C is going to be greater than the third side. A and C or A and B greater than the third side. So all we have to do when we're working through this particular example is we're simply going to look at our 2 sides here and we're going to add them together. So we get 15 plus 14. That gives me 29. So what we're going to do here is we're going to place that in. So that 29 is this part of any of these, doesn't matter which one, but it just states that the sum of 2 sides will always be greater than the other side. So these are other potential sides, 30, 29, 28, and 30. So what we're trying to figure out is 29 greater than those numbers as options. So I'm going to write my little statements of 29 greater than, and we're going to figure out which one of these is accurate. So we see here we have 30. So if we plug that into that statement for that third side, 29 greater than 30. Nope, that's definitely not true, right? 39 is technically less than. So that's not going to be a potential side length. If we continue on with that thought, we plug in 29. Well, it states that 29 must be larger, greater than 29. It doesn't say greater than or equal to, it simply says greater than. 29 is not greater than, it's actually equal to, right? So therefore, 29 cannot be a potential side length. All right, as we continue on, we see that we have 28. So let's see if when we take that in, does it make it true? 29 greater than 28? Yeah, absolutely. 29 is greater than. So 28 can definitely be our contender, but let's just go ahead and double check that last one. as we're moving through. So 31, we plug in 31, 29 is not greater than, it's actually less than. So therefore that's not. So we see that in this particular example, 28 is the only potential side length for that third side, because once again, in this particular problem, you're simply taking the two numbers you have, adding them together, and figuring out which number it's greater than, because that's the only possible value for that third side. Now, in question 6, this one's we're trying to figure out potential interior measurements and values of x's for those interior measurements. But really, ultimately, what this comes down to is not necessarily solving for x. I believe at this point in our 8th grade academic walk in math, we know how to solve for an x. So I'm not going to dive into that part of this particular example you would be seeing. What we're really trying to dive into is what is just simply what it equals. Like, right? Obviously, when I'm trying to find a value of an x, when I have a bunch of side values, I'm simply taking that measurement, all these angle measurements, adding them together to equal what the interior measurements are of that particular shape. Well, we have to figure out, well, what are the particular shape? Now, remember, there were two ways in which we can figure out what the interior angle measurements of a polygon were. One of them was just simply dissecting these polygons into triangles. And so what you would do is you simply connect vertexes like I did here into creating these triangles. But remember, we're not doing it like in the example here. You're not going from one side to the other because you're creating more triangles than you should. So you should never have any intersecting lines. You should be kind of think of it like a piece of cake. You know, when you cut this piece off, you're gone. You cut this piece off, you're gone. You cut this piece off, as you continue to cut. Here, you would be cutting, you're not removing a triangle, you would be removing multiple things here, right? We want to remove a solid triangle at a time. So the whole purpose is that it's because, remember, we know that the interior angle measurements of a triangle is 180 degrees. And so that's going to tell me, well, if I have 4 triangles like I do in this particular shape, we know that we have 480 degrees in total. So we're able to take 180 degrees and times it by 4 to give me my interior measurement. So we see that in our hexagon here, it's 720 degrees. Now, the other way that we could do it, remember, was by counting the sides. So 1, 2, 3, 4, 5, and 6. We have 6 sides. We minus it by 2. Remember that minus 2 was a constant. You would simply count the sides, always minus 2, and that would give you the number in which you're going to need to multiply by 180, which once again would still give us 720. So some students really enjoyed the dissecting polygons into those triangles. Some really struggled with that because it kept doing, like our example here, where the do not do this one is not correct. And so if you were struggling with that, remember, all you had to do was count the sides, subtract 2 from that, then multiply it by 180 to get our interior measurements. Then at that point, I could simply take it, my values here of whatever my x is, whatever these were, take all of these angle measurements, add them together to equal 7. So you would have 6, that angle measurement, that angle measurement. You would add all 6 angle measurements here. 1, 2, 3, 4, 5, 6, and you would set them equal to that 720 to solve for that x. Okay, like I said, not really diving into the solving for x value, because at this point we should be able to solve for a variable, because that is an old skill that we've been practicing all semester long. So if you need additional help on that, go back to that particular live session and rewatch it, or review your notes on those. Now in question 7 and 8, once again, you're going to be asked to solve for a variable based on the sum of an angle of a triangle. We know that the sum of angles in a triangle is 180 degrees, meaning that you can take all those measurements together and simply add them together. 65 plus 55 plus 60. You simply add all those measurements together to get your 180 degrees. And so all you're doing is you're filling in those bits of information. You're going to plug in that whatever value is for A, you're going to plug in whatever value is for B and whatever value is for C. Add them together, set them equal to 180, and you'll be able to then solve for that variable. Once again, I'm not really diving into solving for a variable because at this point we should know how to combine those like terms to get and follow those steps in solving for a variable. But what you need to know with questions 7 and 8 is taking the values, whatever value or whatever equation is in each of those angles, adding them together, and always, 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 always setting it to equal 180 degrees. So that completes our review for basic geometric shapes. Remember, once again, you have a single attempt on this test. Do not speed through that attempt. Make sure you've watched this video, you have taken notes. Make sure you've completed all your modules. Make sure you've completed all your IXL skills because those are going to be the things that are really going to help you practice the skills that are required for you to be successful on that test. Now, remember, you do not gain immediate access to that test. You do have to complete the test prep quiz that is you should be doing as soon as you finish this video, or maybe you're watching this as a review, which awesome job. But you have to answer that test prep quiz in order to gain access to your test, meaning that you've got to answer all 3 questions correctly. All of those questions come directly from this video. So as long as you are taking notes, you're going to be set. First question simply asking you, did you watch this video in the entirety and do you feel prepared? Which of course you should be answering yes to. And the other 2 questions are based off of different examples that I did in this particular review video. If you have any questions, remember, if you want additional attempts on that, you can gain additional attempts. However, you will be required to email your teacher asking for that request, and you will have made sure that you have completed all of your modules and all of your IXL skills because your teacher will not give you any additional attempts if you've not shown remediation through completing those modules and completing those IXL skills, making sure you've also watched this video again to its entirety to make sure you're reviewed. If you have any questions, guys, please feel free to reach out to your teacher. We'd be glad to help you out. Come see us during our help sessions. But with that, guys, have a wonderful day.